Well, a very, very big welcome to you from here in London to my FOSDEM talk. So my talk today is entitled, It's a Bird, It's a Plane, It's SDK Man. A few words about myself. My name is Marco from Vermeulen. I'm a South African who was raised by Dutch parents in South Africa, but I live in London. I've been living here for the last 15 years. I'm a polyglot developer. I work mostly on the JVM on a day-to-day basis. I program in Kotlin and Scala mostly, and also do a bit of Java and Groovy from time to time. I'm currently working for a Norwegian company called Heimstaden, even though I'm based here in the UK. And in my spare time, I'm the maintainer of SDK Man, which this talk is about. So I'm also in the process of writing a book. I'm almost done with it, actually. It will be coming out a little bit later this year, called Functional Programming in Kotlin. It's basically a port of the famous Red Book, the Functional Programming in Scala Red Book, that is very popular among Scala developers, but now for Kotlin developers. Right, let's take a very quick bird's eye look at what this talk is about. Firstly, we're going to be looking at the problem space and what problem SDK Man seeks to solve. We'll be looking at exactly what an SDK is. We'll be looking at the architecture of SDK Man. We'll look at the backing infrastructure. We'll be looking at vendoring aspects for third parties to publish their SDKs on SDK Man. And we are going to look at how you can contribute to SDK Man, because of course it's an open source, a free open source project. And lastly, we'll be looking at what the future holds, because we're always pushing the curve and trying to develop SDK Man to make it better. Right, so let's get right into it. And what better way to do that than with a quick demo to show you what SDK Man can do for you. Right, so let's go straight to the command line. Obviously, SDK Man is a command line tool. So what we'll do is we'll just quickly fire up SDK Man and we'll just say SDK ls, which is list, short for list. So that gives you a list of all the available SDKs that you can get on SDK Man. So as you can see there, there's so many represented. All the major JVM languages are there. Lots of frameworks, build tools. Gradle is there, Grails. We've got Kotlin and HTTP4K. We've got Scala. We've got SBT. So we've got a really broad representation. JBang is there, you can see. So SDK ls or list will give you a list of all the available SDKs. Now, say you want to take a closer look at one of those. You can qualify it by doing that. Now that shows you all the versions that we hold. Now this is the beauty of SDK Man, is it supports multiple versions of an SDK. And you can install them side by side. That's the cool thing. So in other words, if I just want to get the very latest, greatest version of this SDK, I can just say SDK install, or if I want to, just Kotlin. And this will go and get, for me, the latest version of Kotlin. So there you can see it downloading. And once it's downloaded, it'll automatically add it to the path, which means I don't have to go and set up any home variables. I don't have to go and add it to my path or anything, the usual sort of thing that you have to do. This all gets managed for you on the fly. So there you can see it's now installed Kotlin 1.4.21. If I type Kotlin, automatically it just works. There we go. Kotlin. And you can see that's 1.4.21. But now, say I wanted to install an older version. Say I wanted to install Kotlin 1.3.7.2. I can say SDK install Kotlin, and I can qualify the version 1372, and it goes off and it fetches it for you, and it will automatically give you the option to make that the default version. So there we go, that's quickly installing it. It should almost be ready. Fantastic. Do I want to make that my new default? Let's say no for now. So if we say SDK ls Kotlin, you will now see over here that 1421 is still the default, and 1372 is also available. So if I say Kotlin version, if I say Kotlin version like that, it's 1421. But what I can do now is I can open a new terminal and I say SDK use Kotlin 1372. So now I've got one terminal running Kotlin 1372, and I've got another one running 1421. So I can actually run them side by side. Now that becomes particularly useful when you're, for instance, installing Java, multiple versions of Java, and you want to run them side by side. Imagine having Java 8 in one terminal and Java 11 in the other terminal. That's the magic of SDKman, and I think this is the very big benefit of using SDKman, the ability to use multiple versions of the same SDK side by side. Okay, so we just spoke about Java and installing Java and JDKs via SDKman. Now, JDKs weren't always supported in the past. The reason being that SDKs on the JVM are generally platform independent, which means if you download a Scala zip file, you can use that same zip SDK on OS X or Linux or Cygwin and it'll work just fine. But Java is different. Java gets compiled specifically for your platform, which means Java is platform specific. So we did some work in SDKman a while back to enable platform specific SDKs, and Java was the first one that we implemented. This was actually just an enabler to get JDKs working with SDKman. And since that time, this has become the most popular SDK on SDKman. This is actually the thing that has pushed SDKman forward the most, which means you can now do something to the effect of this. You can see this list view. I'm just going to make it a bit smaller. But you can see it. It's a custom list view just for Java. It's the only SDK that has its own custom list view. It's got columns for vendor, and we've got like all these different vendors. You can see adopt OpenJDK, which happens to be our default. Alibaba, Amazon, so that's the Amazon Corretto JDK. We've got Zulu over here from Azul, Bellsoft. We've even got GraalVM, different versions of GraalVM going back, compiled against Java 8 or Java 11. We've got Java, the Java.NET OpenJDKs represented here. And of course, we have SAP machine at the end over here. So SAP provide their own JDK as well. So we've got all sorts of different flavors represented. And these things are always up to date. We make sure that you can always get the latest version of whatever Java vendor you want. You can simply type SDK install Java and the version identifier that you want, and you'll immediately get it on your machine. Super convenient. Right, we've now seen what SDKman can do. We've seen it in action. So let's take a step onwards and let's see exactly what an SDK is. So what is an SDK? So first off, it's just an archive, right? There's nothing more to it than that, really. It's either a zip or it's a tarball. It's usually one of those two. Inside of that archive, there'll be a containing folder, and that folder will normally take the convention of the name dash the version. So, for example, Kotlin 1372 that we looked at, it would be Kotlin-1.3.72. That would be the name of the folder. If we go and peek inside that folder, you would find something that looks like a small Unix file system. So you would see all the regular ones like bin, lib, etc. Bin is the mandatory one because that contains the executable scripts that we want to add to our path. The others are optional. So you'll see a mix of the familiar kind of folders you would see on a Unix file system inside there. The important thing is it's completely self-contained. So an SDK can stand on its own. It will never have dependency on another SDK. The only exception to the rule there would be that most JVM SDKs expect Java to already be installed on the system. So that would be your only real hard dependency. But it's never enforced. You could install an SDK and not have Java installed, and it simply won't run right. So let's take a closer peek at an SDK. Say now we download the Spring Boot 213 release zip from their website. And we run unzip on it, and you can see here, it goes and creates that folder structure. There we go, Spring 213 release. You can see the convention there. And if we now go and run the tree command on that folder, then this is basically what you see. Here you see the enclosing folder, and underneath there you will see the bin folder with its executables. You'll see something like an install file. They've got a legal folder. They've got a lib folder containing the bootstrap jar that actually starts up the Java process. That's probably an executable jar. It's got a license and some shell completion scripts, for instance. Now, what is a package? So we've looked at an SDK. Now, how does that differ from a package? So, packages normally come in extensions like .deb or .rpm. So, in the Linux world, .deb is for Debian-based distributions. Ubuntu is one of those, for instance. RPM is Red Hat package management. So anything that's Red Hat based, like Fedora, for instance, will use an RPM. On Mac OS X, we have DMG and PKG files. And on Windows, we have MSI and EXEs. Now, what differentiates a package from an SDK is the fact that it has a very complex, most of them have very complex internal structures. They normally have all sorts of custom descriptors that their package management system understands. And they'll have certain scripts with pre- and post-install hooks that install certain files in certain places by convention on that system. So this is custom for every distribution and every platform, of course. So there's no consistency between any of these package management systems or their artifacts, of course. And of course, these things are managed by a package management system which actually tracks dependencies. So every package will have an X amount of external dependencies that it will pull in when you install it. And those ones in turn will also have dependencies. So you have this whole DAG of dependencies that gets pulled in when you're installing a single package. So, this is the question for you. Is SDKman a package manager or is it an SDK manager? So obviously it's an SDK manager. It doesn't have any notion of dependencies and it never will. It's purely there to help you in a very easy way. Go and fetch the archives from a remote website. It'll extract it on your machine. It'll manage the location of where that lives. And it'll manage all the path variables associated with that package so that you can use it comfortably from the command line. So, when I started with this project, I had an itch. I had something that bothered me, right? And with every itch there has to be a scratch. I decided to write an SDK manager that would handle the mundane for me. So I found myself working with many software development kits, right, on a day-to-day basis. At the time, I was doing a lot of Groovy and Grails, and I ended up having to download lots of SDKs, lots of different versions of Grails, for instance. And then I had to go and extract those things. I had to download, had to go and find them on the website on a download page. Then once they downloaded, I had to go and extract them somewhere in my file system. Then in my bash profile, I had to go and set up home variables pointing to where my Grails installation lived, for instance. And then I had to go and add those things to my path. And this very soon became old. Obviously, if I had multiple Grails installations, I had to have symlinks pointing to those. And I had some complex thing where I switched symlinks out. Boring, mundane, waste of time. So I decided, let's automate this thing. This is an easy problem to solve. Why not just write something that can do this for you? And this is how SDKman was born. So the scratch was to write an SDK Manager. I wanted it to install multiple candidates. At the time, I was using mostly Groovy and Grails. But very soon I found myself moving into other realms, and soon after that I started doing a lot of Scala. So I was doing the same thing again all over, this time just with different SDKs. One thing I did want though is to have multiple versions per candidate. When I say candidate, that would be something like a Kotlin or a Groovy or whatever gets installed by SDKman. I wanted to perform those downloads for me. I don't want SDKman to actually own the binaries. I just wanted to go and fetch it from wherever it lives, right? I don't want to maintain my own binary registry. That isn't the purpose of SDKman, and it never will be. We simply act as a broker to go and fetch it from its home. SDKman deals with those archives after it's been downloaded. It caches the archives so that they can be reinstalled on your machine. When I say caching, that's a local caching that happens on your machine. So if you uninstall a version of an SDK and try and reinstall it, we'll first see if we already downloaded it before. And then we'll just go and expand it. And of course, we manage all these variables for you, these environment variables. Like for Java, it would be a Java underscore home. For Scala, it would be a Scala underscore home, so forth. That seems to be the general convention in JVM SDKs, is these home folders. So we produce one of these home folders in your shell, and we automatically add that to your path on the fly. You don't have to open a new shell or anything. That thing will simply be added to your path variable, and that allows you to then just type in the command immediately and it'll start working. Another thing I wanted was that this thing would always be up to date. If a new version of an SDK landed, it should immediately become available on this tool. And very, very importantly, it needs to be lightweight and run anywhere. So I want this to be able to run on Linux or OS X or Cygwin or any kind of Unix environment, FreeBSD. In the past, when Solaris was around, it should run on Solaris, you know. So let's take a closer look at the command line interface component of SDKman. So the first thing people always ask me is, why is it written in Bash? Why not in Python or in this or in that or in their favorite language? I get a lot of people asking me, why wasn't this written in Groovy, for instance? So the answer is simple. Bash is super lightweight and it's available everywhere. It's got very fast startup time. If I had to go and write a Java command line tool, I have to sit around waiting for 2 seconds just for the JVM to start up. How inefficient in any case to write a CLI tool and having to spin up an entire JVM just to run a little command line tool. It just seems horrible and very inefficient. So I thought it would just be better to use what was there already. And of course, Bash is supported on so many platforms. You'll have Bash on OS X, Linux, Cygwin, Solaris, BSD. Of course, we don't only support Bash, we support ZSH too. I'm actually a ZSH user. And it's 100% compatible with ZSH2. Of course, there are very few dependencies. The only dependencies that we do require on your system when you install SDKman is curl, because we use curl for the underlying transport to call out to our APIs. We need zip, gzip, and tar as well for dealing with zips, and for JDKs usually we need tar and gzip because those are normally tarballs. Right, so closer look at the Bash client. So when we install SDKman, the first thing that happens is a little snippet gets added to the end of your Bash or ZSH profile. It goes and looks for a file which is in a .sdkman folder in your home, and that thing in turn has a bin folder which contains an sdkman init.sh. Now that thing gets sourced if it's there. So inside that particular file, that init file, what we go and do is we go and look inside of the sdkman directory, inside the source folder, and we go and source all the files that we find in there. Now those files in turn all have a function, a top-level function and some helper functions inside of them. So for instance, the sdkman-help.sh file, which lives in the source folder, contains something that looks like this. It's a function with __sdk_help. Right? Now all these top-level files will contain a function like that, an entry point function. Then if you look inside the sdkman-main.sh, you will see it has a function called SDK. Now this is the interesting part. When you type the SDK command, we're not actually invoking a script or anything. What we're actually doing is we're invoking a function that was sourced into your shell. And as you'll see from this little snippet of code, you'll see that we basically go, and when we type in a command like SDK list, like we did earlier, we take that thing and we use this to compose a function. Like there we go. And when we invoke that, it will actually go and invoke one of these top-level functions. So if I say SDK help, it'll automatically pass through the command as help. It will fabricate the name of that function and invoke it, passing any further parameters to it, and it will fire off that thing. So in other words, it's a top-level function. SDK is a top-level function that calls through to a bunch of other functions. Right, so that all sounds extremely rosy. It sounds great, Bash, right? But there are pitfalls. So the big problem is Bash is very inconsistent. There are so many versions of Bash out there. Everybody's got a different version of Bash running on their machine. Or a different version of ZSH, or different versions of curl, or zip, or maybe even a completely different implementation of zip that behaves differently. We see this often like on Sigmund, for instance, where they have a different version of zip on the class path, or on the path, and it just causes havoc, right? So even though Bash works really well most of the time, you always have cases where there are inconsistencies because of some strange behavior on the person's machine. It's like building on quicksand. Right, so we've taken a look now at Bash. Bash has lots of advantages, but at the end of the day, a native implementation is going to be a lot better. It's going to give us consistent behavior across all platforms. It will run on LLVM, so more than likely it will be Rust, but it could be Go, or it could be something else, but it would be running on LLVM, which is a standard platform. It will enable us to write something that is truly multi-platform, that will not have any dependencies on your local machine. So you won't have to have curl installed, or zip, or gzip, or anything like that. All the stuff gets provided by the standard libraries provided by the language. If we go for Rust, we'll have Rust crates for everything, and we'll be able to pull in an HTTP library and just be able to do all HTTP calls with the backend, and we'll be able to do that in JSON, all transparently. It'll be perfect. Now let's take a further look. Let's go to the backend. So the CLI that you just saw written in Bash is just the tip of the iceberg, because most of the heavy lifting happens on the backend, on the server side of SDKman. So just in short, SDKman is backed by a bunch of microservices. All these microservices run in Docker containers. They are fronted by Nginx. All the microservices are backed by MongoDB, so that is our main database. We also have some stuff in Postgres. I would actually prefer to cut everything over to Postgres in the future, but at the moment it's still mostly on Mongo. I'm a big Postgres fan, by the way. So the API services we currently have, there's a proxy service, there's a candidate service, there's a hooks service. Now that's an interesting one. The hooks service actually serves back snippets of Bash that get executed in line. So in other words, when I'm installing something, you'll see little pre and post hooks that get pulled in, and those all come from the server side. They get served back as little Bash snippets and executed in line, which gives us a lot of power to be able to do cool stuff on your machine, custom to your platform and custom to the candidate that you're installing. We have a broker service. The broker service goes to the database and finds out exactly where a binary lives. So if I'm installing Java, for instance, we will go off to the adopt OpenJDK download site, and we'll actually pull the binary from there. We won't actually store it locally in our own registry, like I mentioned earlier. And we have a broadcast service, so you'll periodically see little broadcast messages appearing in your terminal when you're using SDKman, announcing that a new version of an SDK has been released, for instance. What kind of infrastructure are we using? We've already touched on the fact that we're using Docker, so we're running this all on DigitalOcean. At the moment, we're just spinning up a bunch of Debian instances, and we're actually just terraforming this stuff all. and we're using Ansible to provision Docker on there, and we basically deploy all the Docker images with Ansible. In the future, we might be using Kubernetes. At the moment, we don't have a need for scaling things at all. Everything is pretty solid and stable. We rarely have issues. So what we currently have is very minimalist, but it works. But yes, we could move to Kubernetes in the future. Which brings me to vendoring. So vendoring is an interesting topic. So early on, I found myself being burnt out. I was constantly on the lookout for releases of new versions of SDKs. When it was just a handful of SDKs like Groovy and Grails and Gradle, there weren't that many to maintain. But as the number of candidates grew, I found myself just being burnt out, trying to insert these things into the database all the time, finding the URL, inserting it, doing a broadcast. And at that time, I'd already started building some basic APIs. I just decided we need to look forward and be able to delegate this and empower vendors to be able to do their own releases. In the beginning, the adoption was quite slow because people didn't know what SDKman was. But as time went on, people started coming to us. So it's a secure API. We issue them with some credentials, and they can now call into a vendor API and perform their own releases and do a tweet. They can basically do a broadcast, and that automatically tweets on our Twitter account to announce that a new version of an SDK has become available. We also provide database migrations. So for the community, if they have their pet SDK that they want to see updated, but they're not willing to call through to the API for some other reason, then the community themselves can take this into their own hands and they can write a database migration that will be able to update things based on pull requests in our database. So that brings us to the topic of contributing. So at the end of the day, we are completely dependent on contributions from the people that use SDKman. So we've got an SDKman Slack going. It's a nice and active community. People get on there, they ask questions, they make suggestions for new features. That would be the place to start off. Become part of the conversation. Once we identify a bug or a new feature or so forth, then we normally ask people to go to GitHub and create a new issue around it. And then they are welcome to go and raise a pull request according to our contributor guidelines. We've got some nice guidelines set up. We love everything being covered by tests. We make heavy use of Cucumber, actually, to do very feature-driven development. So we've got a whole suite of Cucumber specs that run against the CLI to make sure that everything is working exactly as we expect it to. And of course, another great way to get involved is by doing these database migrations. So if you've got a project that you would like to see on SDKman, please, by all means, go ahead and raise a PR against the database migration repo to go and add your favorite SDK. And when new versions come out, raise a PR and it'll automatically become a part of the SDKs being served by SDKman. So that is it for me. And now I welcome any questions that you might have. So thank you very much.